Good day, friends of Buzzy. Welcome to your coronavirus and pain management update. Today we're going to talk about the math of herd immunity, or the math myths of herd immunity. We're going to talk about a new article in the medRxiv preprints that I think is the Rosetta Stone that will be looked at later to go, yes, this ties everything together. And then talk about some of the specific coronavirus pain issues that are starting to crop up because people are doing the same exercises over and over again. So I'm Dr. Amy Baxter, CEO of Pain Care Labs. We make VibraCool for general pain, Buzzy for injection needle pain, and I am an emergency doctor. So when something seems to be a crisis, I tend to run toward it instead of away. Coronavirus is one of those kinds of crises. So in March, I got distracted from my normal research on vibration and low back pain with the NIH and started doing a little COVID interest research on the side. So today's episode, let's start by talking about the math myths of herd immunity. So the issue with herd immunity is that depending on how transmissible coronavirus is, they call it the R-naught, it determines, just through a mathematical formula, how many people need to be immune to the disease, either through natural immunity or a vaccine or having already caught it and not being able to get it again. Those are the things that determine whether or not the community at large can get coronavirus. So if we assume that the number of people that coronavirus infects is between 2 and 3, so each person gets 2 to 3 people sick, that is an R-naught of 2 to 3, that would mean we need about a 70% herd immunity. So 70% of people need to be immune to slow the spread down to where it goes underground or disappears. There is this theory that in New York, where almost 20% of people have coronavirus antibodies, that because they're not catching the disease so much and it's going down, that maybe the herd immunity is achievable for the rest of the country. So here's the math and the problems with that. So I do believe that probably about 50% of people have some immunity from other coronaviruses. It's a T-cell mediated immunity, whether they are the ones who are getting mildly sick or whether they're not getting sick at all. They kind of count in the group that are not as likely to spread. This is different from asymptomatic spread, where you can certainly spread it, but these people have an immune response that is stopping them before they can spread it to other people. So let's say, for the sake of argument, that 50% of people do have T-cell immunity from other common colds they've caught before. Now, let's say that we only need to get 20% of people infected to get to herd immunity. The problem with that is that the death rates for coronavirus came out this week in Nature, and it is highly related to age, as we knew. So basically, statistically, you've got no chance of dying if you're under the age of 50. Between the ages of 65 and 74, it's about 3.1% chance. And the chances of dying if you are 75 or over, 11.6%. So let's do the math on how many people would be included in that 30% of random people who are not immune. So if we say that in order to get to the place where we need to be, we've got to get 20% of people with herd immunity. And so that means that around 30% of people are going to be infected and not die. But looking at these numbers, so let's just say we've got those Nature statistics. So if we take 30% of the population, so we've got 330 million people in this country, 30% is roughly 100 million. Now let's say we want to get up to herd immunity. So we want to have what happened in New York. We want the deaths in New York to just flash through so that we can get to that place where 20% of people have antibodies. That means that of that 100 million people, you're going to have on average about a 2.1% case fatality rate on average. So that means that 2 million more people are going to have to die for us to get to a place where we have 20% antibodies, and then that's even hoping that we get 50% who are immune from the T cell thing. So the problem with herd immunity is that just like in New York, if it is allowed to spread randomly, then you're going to end up with morgues on the street in refrigerated cars. So really, trying to just let herd immunity spread is not a plan that makes sense. One of the things that came out this week that I think really underscores part of the problem with this herd immunity plan is that we already know we have a very disproportionate burden on people who are Hispanic, people who are African American, and males. And we haven't really known up until now 100% where that's coming from. So this preprint came out that to me is just, it is like the Rosetta Stone. It ties everything together. So what they did, and this was an NIH-sponsored R01, which if you're into research is kind of the king daddy of grants. That's the one like, ooh, they've got an R01. So this R01 looked at the nasal swabs of something like 537 children. And because they had such a big number, they were able to look at the ACE2 receptors of a whole bunch of different variables within the nasal swabs of these children. So you know that we've talked about how the activated ACE2 receptors in the nose combined with the TMPRSS2 gene that's activated in the nose, those two things are required for you to get coronavirus, the SARS-CoV-2 virus into your body, that it really starts in the nose. What they found was there was a methylation of the DNA that made it more likely for the coronavirus to be able to attach and enter. And the percentages by race, by age, by gender, everything else, what they looked at, they found was in these kids that the likelihood of the DNA to methylate to make it so that it was easier for the SARS-CoV-2 virus to attach, it was 5 times more likely in Latinos. It was 8 times more likely in the Black children. And I think the thing that was, to me, the most profound was they didn't find that age was related to this. What they did find was that telomeric shortening was related. Now, big whoop, right? What does that mean? What that is and what that means is probably about 10 years ago, scientists started realizing that age is not just chronologic, it's wear and tear. As Indiana Jones says, it's not the years, it's the mileage. Telomeres are a good indicator of the mileage that you've gone through. And a huge finding was that Black population has disproportionately much shorter telomeres in the US than in other countries compared to whites, compared to other races. There is a presumed stress that just comes from having to be Black in America. In fact, telomeric shortening is probably one of the best indicators of systemic racism that there is, because it demonstrates that the stress of being in America artificially ages you. So anyhow, that's why I think that this is just an amazing piece of work, because it shows that there is something about your mileage, your telomeric shortening, the DNA, and that gets shorter over time, that is correlated with the likelihood that the virus can attach. That race is highly correlated with the likelihood that the virus could attach. And the fact that all of these numbers fit with the model of an aerosol and respiratory virus that enters through the nose, that the numbers that they got from these nasal epithelium match the pattern that we're seeing that has been such a mystery for coronavirus. What is it about this that hits certain people so disproportionately hard? Well, it may be that it's easier for the virus to get into them, and that's purely a random DNA genetic methylation issue that may not be so random. So anyway, to me, I know it's a very heavy on the biochem kind of explanation, but I got excited about it. All right, so those are the two big takeaways from this week, is that we're closing in on knowing how many people are going to die, which means that the math of herd immunity is a myth. In terms of it being a good idea. We have a cool new paper that is supportive of the science and may be helpful in understanding a little bit of what a weird distribution we have, so we know who to protect more and we know how this spreads. And finally, one of the interesting things that I learned today about coronavirus is that the exercise equipment in the sports and physical therapy markets have completely changed over the last 6 months. And the way they have changed is based on home exercise. So first of all, you can't get a set of 2 and 5 pound weights because everybody is getting those weights to do at home. Exercise bands sold out almost everywhere because people are trying to get those to do at home. And injuries that are starting to pop up are overuse injuries from walking and overuse injuries from doing bicycling routines and elliptical routines at home for people that have one machine and that's all they're doing. So the thought of there being a run on 2 and 5 pound weights was funny to me, but I will tell you that even though we do have an exercise band in our Flex, I'm not going to show you that, but we have been selling a lot of the VibraCool knee units. So this is a VibraCool knee unit, the extended, because the vibration unit that's in it can go for an extended amount of time. And this is the pocket that comes out of the Flex, so you can attach it to the knee unit. So if you are home and if you have a nagging place in your knee, in your ankle, plantar fasciitis, what you want to do is before you start working out, before you start exercising, put on just the vibration part. So what this is going to do is it's going to loosen up the area that's gotten stiff and tender because you're using it too much. So this is a way to exercise that and almost like stretching, but more efficient and a little faster. So that delayed onset muscle soreness thing, do the vibration only first, and then after you finish the workout, that's when you want to add the ice pack. So then you put, this is actually for the elbow unit, but golfer's elbow is probably not as big a thing for most people now. So then you put the ice pack on and then put this around the knee or wherever you're hurting after you do the exercise. And of course, try to switch up your exercises as much as possible. All right, as always, please like, subscribe. I'm trying every week until this crisis is over to synopsize the research that's come out, put it in context of why it matters, and try to give some tip or trick or something that can make getting through the coronavirus pandemic era a little bit easier. Thank you for tuning in, and until next time, when I'm very sure it's going to be fine.